Well, today we're going to look at the derivative of general logarithms. Our last logarithm in this unit, or our last derivative rather in this unit, so y equals log of x to base 2, what's its derivative? Well, I thought it would be good to recap the previous three derivatives and where they came from. So we're going to go through those basics first, and then I'll give you this derivative right here, and we'll do a little practice of it. And that will represent the last derivative that we do in this unit. So our first derivative we did was of e to the x, and we did that one by first principles. We said y prime equals the limit as h approaches 0 of e to the x plus h minus e to the x all over h. And that's the first principles formula. We said that first term in the numerator can be broken up to be e to the x times e to the h minus e to the x all over h, so that when you're multiplying, you add the exponents, and we just went the reverse of that. That leaves a common factor in the numerator. Of e to the x, and you get e to the h minus 1 over h. Well, since this is variable x and h approaches 0 does not impact that, you can common factor out e to the x in front of the limit. And then the question becomes, what's the value of this limit? So we did that by making a chart. We found the value of this limit by making a chart. We said, what happens as h gets smaller and smaller and smaller, approaching 0? And we considered the value of this. And so I did that on my calculator, and I got these values. As h was 0.5, we had 1.2974425. And then when h went to 0.1, I had 1.05170918. And then I had 1.0050160 when h was 0.01. And then 1.00050016. And I had one last calculation, usually a bit further than we go. 1.0000123450002. So the suggestion was that as h got closer to 0, e to h minus 1 over h got closer and closer to 1. So y prime equals e to the x times what we determined to be the limit of that expression equaling 1. So our first derivative was the only one we did by first principles. After that, we started looking at other logarithmic and exponential functions. We looked at the natural log, the ln of x, which we said really was a nickname for the log of x to base e. In order to establish this derivative, we said let's write it in exponent form. If the log of x to base e equals y, then e to the y equals x. That's taking a logarithm and writing it as an exponent. So you should be able to go either way with that. So if e to the y equals x, we can use this derivative down here to help us. So the derivative of this would be e to the y times the derivative of the exponent, dy over dx, equals the derivative of x, which is 1. So dy over dx equals 1 over e to the y. And earlier we said e to the y equals x. So dy over dx equals 1 over x. That was the second derivative we established here. If y equals ln x, the log of x to base e, then dy over dx equals 1 over x. And then we looked at general exponential functions. What about y equals 2 to the x? So what we did with a question like that was we said we're going to change it to a natural logarithm by taking the ln of both sides and using our down in front rule. So ln y equals x times a constant of ln 2. That's just a constant just a number. So the derivative of ln y, according to what we learned up there, is 1 over y times the derivative of the argument, dy over dx. And that's equal to the derivative of x times a constant is just a constant, ln 2. So then we took that and multiplied both sides by y, so that we could cancel this y off with this y, and we were left with dy over dx equaling y times the constant ln 2. And what was y equal to? Y was equal to 2 to the x. So we said dy over dx is equal to 2 to the exponent x times this ugly constant ln 2. So those were the three derivatives that we established earlier in the unit. Now we're going to take a look at how to establish the derivative of a general logarithmic function using those as our anchors. So what's the derivative? What's the derivative of y equals 2, the log of x to some base 2, not e. So we're going to take this and we're going to write it in exponential form. 2 to the y equals x. And we just established the derivative of things like this. So the derivative of 2 to the y is itself times the ln of the base times the derivative of the exponent. And the derivative of x is 1. So dy over dx equals 1 over 2 to the y times ln 2. dy over dx equals 1 over, and what does 2 to the y equal? And we could substitute that down there. 1 times x ln 2. So we're replacing 2 to the y with x. To summarize, we will look at this little chart. If y equals e to the x, y prime equals e to the x. Compare that to a general exponential function like 10 to the x. Y prime equals 10 to the x. You see the similarity there, but you need to multiply that by the ln of the base. Y equals ln x. That's the natural logarithm, or the log of x to base e. Y prime equals 1 over x. Compare that to y equals the log of x to base 5. You would say y prime equals 1 over x. That's the similar part, but you need to multiply it by the ln of the base. So this is the derivative that we're going to be working with today primarily, but these are the 4 derivatives that you should know. So let's begin with some examples. Y equals the log of x. Remember, that means base 10. So y prime equals 1 over x times the ln of the base. And the base is 10, so we would say ln 10. If y equals the log of x to base 3, then you'd say y prime equals 1 over x times the ln of the base. Let's take and make these questions combine other rules. For example, let's look at a product rule question. Y prime equals the first, x squared times the derivative of the second, 1 over x times the ln of the base, plus the second, log of x to base 2 times the derivative of the first. The derivative of x squared is 2x. Let's see if we can simplify that a little bit. I see these x's will cancel out here, and I have x over ln 2 plus 2x times the log of x to base 2. and there's a common factor there of x that you can take out. So 1 over ln 2 plus 2 log of x to base 2 would be a good simplification for that derivative. Let's look at a quotient rule question. Y equals the sine of x all over log of x to base 3. So y prime equals denominator log of x to base 3 times the derivative of the numerator, cos x, minus the numerator, sine x, times the derivative of the denominator, 1 over x ln 3, all over the denominator, log of x all squared. So now we're taking a look and seeing what we can do to simplify that. There's not tons. We've got cos x log of x to base 3 minus sine x times 1 over x ln 3 all over log of x to base 3 all squared. So I think what I'll do to simplify that is multiply everything to get rid of this denominator right here. I think I'm going to multiply everything by x ln 3, x ln 3, x ln 3, and we would get our final answer to be this: y prime equals x ln 3 cos x log of x to base 3 minus sine x all over x ln 3 log of x to base 3 all squared. What happens if the argument gets complicated? What happens if we're doing y equals the log of x cubed plus 7 to base 4? You would say y prime equals 1 over the argument times the ln of the base times the derivative of the argument. So y prime equals 3x squared over x cubed plus 7 times the ln of 4. And if the argument can be simplified using the laws of logarithms, you will do that first. So in this case we have a quotient for an argument. We're going to separate that into two separate logs. We're going to say the log of x cubed plus 7 minus, because it's a division, the log of x squared plus 5. So this is implied base 10. We don't write that in. So y prime equals 1 over the argument, x cubed plus 7, times the ln of the base times the derivative of the argument, minus 1 over x squared plus 5 times the ln of the base times the derivative of the argument. Looking for a common factor there, I see x over ln 10 as a common factor, and that leaves me with 3x over x cubed plus 7 minus 2 over x squared plus 5. So I've run out of boards here. I think I'll do maybe 2 more questions. If you give me a second, I can erase a couple of these boards. You can entertain yourself there while I'm doing this. Y equals the log of x squared to base 3, and we want to find the equation of the tangent line. at x equals 27. So let's take a look at this expression right here, and let's recognize that we can simplify it first by using the down and front rule. So y really equals 2 log of x to base 3. So now let's see what the value of the ordered pair will be at x equals 27. So 2y equals 2 log of 27 to base 3. Y equals 2 times, and what's the log of 27 to base 3? That's like saying 3 to what exponent gives you 27? Well, it's 3 cubed, right? The log of 27 to base 3 is equal to 3. So y equals 6. So you have an ordered pair of 27, 6. Now let's see what y prime equals. Y prime equals 2 times 1 over x ln 3, like that. And we would say at x equals 27, y prime equals 2 over 27 ln 3. So there's your slope, and there's your ordered pair. Y minus y1 equals m onto x minus x1. Using this formula, we can find the equation of the tangent line at this particular point. So y minus 6, that's y1, x1, and m, the slope, equals 2 over 27 ln 3 times x minus 27. So y minus 6 equals 2 over 27 ln 3 times x minus, and as we multiply those, the 27's cancel, and you get 2 over ln 3. So y equals 2 over 27 ln 3 times x minus 2 ln 3 plus 6. And there's the equation of the tangent line. Tangent to that curve at x equals 27. So one last one here. Let's try the log of x plus the log of y equals y squared. Now that's an implicit differentiation. 1 over x ln 10 plus 1 over y ln 10 times dy over dx equals 2y times dy over dx. So we started with an implicit function, and we multiplied and we took its derivative. You can see 2 dy over dx in there. I think I'll multiply everything by xy ln 10 to get rid of those denominators. And you can see this ln 10 will cancel like that. This x will cancel. This y will cancel. And you're left with y plus x dy over dx equals 2xy squared ln 10 times dy over dx. So let's get those terms on the same side. 2xy squared ln 10 dy over dx minus x dy over dx. And now we can common factor y equals dy over dx to xy squared minus x, 2xy squared ln 10 minus x. So y over 2xy squared ln 10 minus x equals dy over dx. And there is a common factor in the denominator of x. So you could say 2y squared ln 10 minus 1. So y over x times 2y squared ln 10 minus 1 is equal to dy over dx. Have a great day.